Okay, grade 8, this is your volume answers to your volume exam. Follow along as we do so. Don't just fast forward to the answer, press pause, and copy everything down. Listen to the explanation, and then press pause. So the first question is a true or false. This is a cube with an edge length of 5 centimeters. So the first thing I would likely do is actually draw that cube and put the edge length of 5 centimeters. And if it's a cube, I know that all the edges are 5 centimeters. And it would have a volume of more than 100 centimeters. Well, since it's a cube, we know that the formula for volume is area of the base, and this base is a square, right? So it would be side squared multiplied by the height. So 5 squared multiplied by the height, which is 5, would be 25 multiplied by 5, which means the volume of this particular cube would be 125 centimeters cubed, which, since it says more than 100 centimeters cubed, your answer would therefore be true. That is a true statement. Your second question gives you two prisms. One is a cylinder and one is a rectangular prism. It says this cylinder here has a greater volume than the rectangular prism. So for both of them, I'm going to use the same formula, area of the base multiplied by the height of the prism, area of the base multiplied by the height of the prism. This one will use 3 multiplied by the radius squared times the height of the prism, which is 8, is 3 times 16 multiplied by 8, which is 48 times 8, which is, oh, my brain's not working this morning. 48 times 8 is 384. So the volume of that cylinder is 384 centimeters cubed. The rectangular prism would be 10 times 6 multiplied by the height, which is 6, or 60 times 6, which is 360 centimeters cubed. Therefore, this does have a greater volume, and the answer is true. So the next question says 1 liter is equal to 100 cubic centimeters. And what we said before is 1 liter, or actually 1 liter is equal to 1,000 cubic centimeters. So what we said before, because 1,000 milliliters is what 1 liter is equal to, and 1 milliliter is equal to 1 cubic centimeter of space, if we're talking about water, and therefore that would be false. It's actually 1,000 cubic centimeters. The next question says this container, almost half a liter of water. So the first thing I'm going to do is calculate the volume. There's my formula, area of the base times the height, or 20 times 4 times the height, or 80 times the height, or 480 cubic centimeters. Now, in the last question, we said that 1 cubic centimeter equals 1 milliliter. So therefore, this would be 480 milliliters. Now, half a liter, since 1 liter is 1,000 milliliters, half a liter would be 500 milliliters. 480 is pretty darn close to 500, so the answer, therefore, I was looking for was true. Now, some of you have actually said false, but you had all the work and said 480 milliliters, so I probably gave you at least 3/4 of a mark for that, even if you had the wrong answer. What is the volume of this prism? This one was probably the worst done out of all of them. Now, if I had drawn the prism like this, most of you probably would have had it right. But remember, a triangular prism, the base of a triangular prism is the triangle itself, which means the height is going to be, if I think about this one reorientated like this number here is really the height. So we have the area of the base multiplied by the height of the prism. That's a different h altogether. The base of the face is 6. The height of the face is 3. Multiplied by the height of the prism, which I think about 1/4 of you had wrong, is 10. That's half of 18 times 10, which is 9 times 10, which means the volume of that cylinder is 90 cubic centimeters of space. What is the volume of this cube? Okay, so area of the base times the height of the prism is our formula for the volume of the cube. 4 squared multiplied by the height of the prism, which is 4, makes this 16 times the height of the prism, which is 4. And 16 times 4 is 64. And our units are meters squared. A lot of people forgot to put the units in. So if you forgot to put the units, make sure that when you are doing questions like these, especially when it comes time to tests, that you write the units, because it really does explain cubic meters. Look, I did the wrong thing. Because it explains what you know. You know the difference between surface area and volume, right? You know that's a cubic meter. Question 7, what's the capacity of this container? So another way of saying what's the volume? This is actually 8 centimeters here. If this is 8 centimeters, and this is 8 centimeters, and this is 8 centimeters, so the area of the base will be 8 times 3, multiplied by the height of the prism, which is 12. That's 24 times 12, which is 288 centimeters cubed. That is the capacity, or how much space is inside this particular prism. The next one is not really a volume question at all, but it kind of is. It says this 2-liter container of Neapolitan ice cream is 31% vanilla, 34% strawberry, and 35% chocolate. What is the volume of each flavor in milliliters? So since this is 2,000 milliliters, that's the first thing you had to know. And 31%, this is for vanilla, 31% of 2,000 would be 0.31 times 2,000, which is 620 milliliters of vanilla ice cream. Likewise, I can do that with strawberry. This is strawberry, which is 680 milliliters. And the last one would be chocolate, which is 0.35 times 2,000, or 35% of 2,000, which is 700 milliliters. And we'll know that's right if we added all three of these together. We get 2,000 milliliters, or 2 liters. The next question gives you 4 different shapes. Right, this one, and then it asks you what is the volume of each. Okay, so the first one is a cube with a side length of 2.5. So there's my formula. So it's 2.5 squared multiplied by 2.5, which if I take my calculator and go 2.5 squared times the height, which is 2.5, I get 15.625 centimeters cubed of volume. The next one's a rectangular prism, so there's my formula. The length is 10, the width is 1.5, the height is 4. 10 times 1.5 is 15 times 4, which is 60 cubic centimeters for that one. For your triangular prism, we have a small h and a big H. This is the height of the face, and this is the height of the prism. So we have to make sure we differentiate between those two. So it's base times height divided by 2 multiplied by the big H, which is 5 times 5 divided by 2 multiplied by the big H, which is 10. That is 12.5 multiplied by 10, which is 125 cubic centimeters of space, which is the volume of that triangular prism. And finally, the last one, your cylinder. So there it is there, your cylinder. The diameter is 12, the height is 20. So if the diameter is 12, the radius is half of that, which is 6. So my formula is pi r squared times h, or pi multiplied by the radius squared times the height, or 3 times 36, that's what 6 squared is, multiplied by the height, or 108 multiplied by 20, which is 2160 centimeters cubed as a volume. This container is 60% full. How many milliliters of water is in the container? So the first thing I'm going to do is figure out if it was full, what would the volume be? So it's a rectangular prism, so there's my formula. Substitute the parts I know, which is the length, width, and height. Simplify it, and I get 3,200 centimeters cubed of full space. Now, since it's 60% full, 60% of the full volume is really 60% of the full volume. Take my calculator and go, what is 60% of the full volume? And the answer is 1,920 milliliters of water, or just under 2 liters. If this is 576 milliliters of liquid right there, that's 576 milliliters of liquid, and that it's in that container, what is the height of this? So the volume is equal to the area of the base multiplied by the height of the prism. The volume we know to be 576, pi we know to be 3, the radius we know to be 8, and the height we don't know. When I simplify that pi r squared, I get 64 times 3, which is 192 times h. And instead of saying 192 times h, I can really think of it algebraically as 192 times h written algebraically. Divide both sides by the coefficient, and the reason why we do that is because we want to isolate for h, and when we do so, we get the height is 3. So therefore, the height of that water would be 3 centimeters tall. A cubed aquarium. Okay, so I'm going to draw it first, a cubed aquarium with an edge length of 10 centimeters. That's a very small aquarium. That's like for, I don't even know what would fit in there. So 10 centimeters by 10 centimeters by 10 centimeters is 80% full. So the first thing I would likely do if this was my test question is draw that. And the first thing I'm going to do before I even read the next sentence is calculate the volume of that. So 10 times 10 multiplied by 10 will be 1,000 centimeters cubed, or if it's water, 1,000 milliliters. And if it's 80% full, 80% of that is 800 milliliters of water. That's what's in the tank to start with. But then what we do is we put in a cube that is 5 by 5 by 5 into that water. And what that's going to do is it's going to raise the water level equal to the volume of that cube. So 5 by 5 by 5, so area of the base times the height, will give me a volume of that cube of 125, which means that's the volume that the aquarium increases. So if I add on to that 125 milliliters or centimeters cubed, it will now have a volume of 925 centimeters cubed, which means will it overflow? No, it will not, because the maximum volume is 1,000 cubic centimeters, and since it was 800 mils in the tank and it increased by 125, it's still shy by about 775 milliliters. For the second part to that question, let's scroll down here. Second part to that question says, if it overflows, how many mils will spill over? But if it doesn't, what percent of the cube is full? So the maximum volume in that cube is 1,000. There are 925 milliliters out of that 1,000 full, which means, as a percentage, that would be 92.5% of the aquarium is full. Okay. The second question, well, the next question, excuse me, says, what is the largest size cubed box with no decimals that can contain 4 liters of liquid? Remember, it says 1 liter is 1,000 milliliters. So 4 liters would be 4,000 milliliters, which is equal to, as far as space goes, if it's water we're talking about 4,000 cubic centimeters of space. So really, if I draw this cube here, the volume equals 4,000. So this number multiplied by this number multiplied by this number, or one number multiplied by itself is 4,000. If I take my calculator, there's actually a button on there that will do it for me. If I put 4,000 in, and right here I have what's called the cube root button. If I hit that, it tells me what number approximately multiplied by itself would be 4,000. So 15.874 times 15.874 times 15.874 is approximately 4,000. And I have to keep writing, but that's approximately what it is. But it says you can't have decimals. So therefore, since you can't have decimals as a side length, the minimum side length you would have would be 16. So I'll go 16 times 16 times 16 equals, the volume of this particular cube that'll hold it is 4,096 milliliters. Another way I could have done is just put 16, and right here I have the cube button. So if I hit that, it actually multiplies 16 by itself 3 times. And it's called cubing it, which is the shape of the object itself. And I would find out that volume would be 4,096 milliliters. That's the first part. Okay, that's the minimum size. The second part said what percent would be full. Since the 4 liters take up 4,000 milliliters, and it's in a container that has a capacity of 4,096, As a fraction, it's 4,000 out of 4,096 milliliters or cubic centimeters. That we can change to a percentage by dividing the numerator by the denominator, and we get 0.9765625, or approximately 97.6%, or 97.7%, or if you wanted to round it to the nearest percent, approximately 98%. All of those are fairly good answers. Next one is a bucket of water is removed from an aquarium. What is the height of the remaining water? It's the last question. So the first thing I want to do is I want to calculate how much water was in the aquarium to begin with. So for me, what I like to do is I like to change these numbers from meters to centimeters, but I'll just do that underneath here. So 4.8 meters is 480 centimeters. 0.9 meters is 90 centimeters. And 2.2 meters is 220 centimeters. So the first thing I'm going to do is I'm going to change those so that I'm dealing with non-decimal units. I just prefer to use non-decimal. And over here, 1 meter and 1 meter, I'm going to change those while I'm here. 1 meter is 100 centimeters. And the height of that is also 1 meter, which is 100 centimeters. So the first thing I did was really just change everything over to non-decimal numbers. Okay? Oh, hang on. All right, whatever. Put that up here. Okay, that's how you're going to play this game, is it? Mm-hmm. Try that again. So this is 220 centimeters. Just ignore that. Okay, so the area of the base times the height of the prism will be 480 as your length of your aquarium, multiplied by the width of the aquarium, multiplied by the height of the total aquarium, which is 220. So if I multiply that all out, the area of the base times the height of the prism equals 9,504,000 cubic centimeters of space. That's what the whole aquarium is. But we know that it's not full, right? We know that that aquarium is only 40% full. So really, what I want to do is I want to find out 40% of that. So if I multiply that by 40%, I get the volume of water that is in the aquarium to start with. I'm going to do that in green. It's 3,801,600 milliliters. Or if I wanted to change that over, it's 3,801 liters of water, right? But we're not. We're just going to keep it in that. So from that container, I'll keep a calculator down here. This how much water was in it to start. And then this bucket of water was removed, okay? So we're going to find out what volume of water was removed by using this formula here. Pi times the radius squared times the height will be 100 squared is 10,000 multiplied by 100 will be 30,000 multiplied by 100, which is 30,000 plus 2 zeros, which is 3 million. So that bucket had a capacity of 3,000 milliliters, which is a pretty big bucket, or 3 million, excuse me. So I'm going to subtract 3 million from what was in the aquarium to begin with. And if I take away 3 million milliliters from a 3,801,600 milliliter tank, the amount of water left over in that tank will be this much here. Okay? So that's the first answer, is how much water will be there? 801,600 milliliters, or 801.6 liters of water will be left in that tank. When I go on to the next part was not written on this one, but it said what percent, or what is the height of the water in the tank, okay? What is the height of the water in the tank? So if this is how much water is left in the tank after that bucket is removed, okay? And that's how much water the whole tank could hold, then 801,600 out of a full capacity out of 9,504,000, this will tell me what percent of the aquarium is full, okay? Let's think about that again. This is how much water is left in the tank. This is how much it can hold maximum. So what's in that tank after the bucket is removed is going to be this fraction, which we can express as a percentage. So if I take my calculator, right, and go 801,600 divided by the capacity of the aquarium, as a percentage, that means that it's about zero. So as a decimal, it's this. As a percentage, it's approximately 8.4% full. Okay? So 8.4% of the tank is full. Since the height is 220, then 8.4% of that total height of 220 centimeters is how high it's going to be. So if I say to myself, what is, so I have to change that 8.4, so 0.084, 8.4% of the 220 centimeter height that would be maximum, it tells me that 18.48 centimeters is 8.4% of the height. So therefore, the final answer, what is the height? It's approximately 18.4 centimeters tall after the bucket is removed. That was a tough question, but there's a lot of work there, but hopefully you understood it.